So this is just an additional topic, or this is just to give emphasis to one of our topics, which is the bandwidth. All right, so when you say bandwidth, it is the portion of the electromagnetic spectrum occupied by a signal. So we'll go deeper into this later. So it is also the frequency range over which a receiver or electronic circuit operates. So it is the range. So pag sinabi mong range, it's just the highest minus the lowest. Tama po ba? So yung bandwidth mo that is just the higher frequency limit minus the lower frequency limit, or the F1. So to give more emphasis, let's have this example. So for example, commonly used frequency range is 902 to 928 megahertz. So you're given here with two frequency limit, one lower and one higher. Now the question is, what is the width of this band? We see width of this band, we are also asking for the bandwidth. So we are given with F1 and F2, and we already have the formula wherein bandwidth is equal to F2, or the higher frequency limit, minus F1, or the lower frequency limit. So simply substitute the given. So you have 928 minus 902, which is equal to 26 megahertz. So thus, over this frequency range, that gives us a 26 megahertz bandwidth, right? So another example, a television signal occupies a 6 megahertz bandwidth. If the low frequency limits, you're given with the low frequency limit, or that is our F1, and we are also given with the bandwidth. So if the low frequency limit is of channel 2 is 54 megahertz, what is the upper frequency? Right, so going back to our formula, if this is our formula, we are given with the bandwidth, we're given with the lower frequency, would help us solve for F2, or the higher frequency limit. That gives us a formula of F2, which is equal to bandwidth plus F1. So we have here F2 is equal to bandwidth plus F1, so that is 6 plus 54, and thus we have the higher frequency limit of 60 megahertz. And if you try to check this one, so if the higher frequency limit is 60 megahertz and the lower is 54 megahertz, if you try to subtract them, there is a difference of 6 megahertz, and thus that is your bandwidth, which is true to the given, which is 6 megahertz daw yung ating bandwidth. Alright? So I hope it is clear that bandwidth is just the range of frequency, and thus the higher frequency limit minus the lower frequency limit. Okay, so channel bandwidth. You also have the term called channel bandwidth. They say that when information is modulated into the carrier, diba? We've already talked about modulation. So when the information is modulated into a carrier, or when information is used to modulate a carrier somewhere in the electromagnetic spectrum, the resulting signal occupies a small portion of the spectrum. So kapag ka na-modulate na ng ating information, yung ating carrier, which is high frequency, meron daw resulting signal, nag-occupy yun ng signal, okay, a small portion of the spectrum. It's not just, so yung resulting information natin is just, not just your frequency, the frequency of your carrier, but somehow nag-occupy pa siya ng more space. Okay, bakit? Bakit not just, say for example, our carrier frequency is, example lang ha, 5 megahertz. So, pag minodify mo yun, di ba nakita niyo sa figure, the frequency is not the change. Say for example, amplitude modulation tayo. So sa amplitude modulation, we are just changing the amplitude of our signal of the carrier, di ba? The frequency, we don't touch it. So ibig sabihin, after modulation, supposed to be meron lang tayong frequency which is equal to the frequency of the carrier. But that is not the case. Okay? The signal, resulting signal occupies pa a small portion of the spectrum. Meron pa siyang ina-occupy na portion. Bakit? Because modulation process causes other signals. Okay. Nagkakaroon ng other signal, which is called the sideband. Always yan. Always remember na kapag ka nag-modulate ka, you're also creating other signals, which is the sideband. Okay. To be generated at the frequencies above and below the carrier frequency by an amount equal to the modulating frequency. Nagets ba to? Alright, so parang ganito siya. if you try to look at it on the frequency domain, say for example, andito yung frequency ng ating carrier. Okay, meron siyang frequency. Now, kapag ka nag-modulate ka daw ng ating frequency ng carrier, alright, ginamit mo yung iyong information to modulate the carrier, nagkakaroon ng sidebands. Ito na yun. Sidebands. Dalawa. Okay. Yung first is, that is just, if you notice, yung frequency na po-produce is that's the carrier frequency plus FM. What is FM? This is the frequency of your modulating signal. Say for example, your voice. Okay? So nagkakaroon ka na ng isang frequency dito and another signal of this frequency which is FC minus FM. Okay? So in totality, yung nako-consume na space or portion in the electromagnetic spectrum is equal to twice your FM. It's not just the FC alone, but it is twice your FM. Bakit twice? Kasi galing dito papunta dito, this is FM, nadagdagan ng FM. Tama po ba? Galing dito papunta dito, nadagdagan din ng isang FM. So in totality, yung na-consume niya na space kapag nag-modulate ka ng signal is twice your FM. Okay, again, remember that if you modulate the signal, there is a resulting other signal which is called sideband. Okay, yung frequency ng sideband na yon is, first, is meron kang FC plus FM. Yung second sideband has FC minus FM. Alright? So, balikan natin yung definition. Again, sabi, the modulation process causes other signals. Okay, pag nagmo-modulate ka, merong ibang signal na nabubuo. Ang tawag doon is sidebands to be generated at frequencies above and below the carrier frequency. Yan na yan. Okay? By an amount equal to the modulating frequency. So for example, an AM broadcasting audio signals up to 5 kilohertz. You have an audio signal which is 5 kilohertz. Audio signals, this is also your intelligence. Tama ba? Ito yung ating baseband. Ito yung unmodulated signal. Siya yung magmomodulate sa ating carrier. Okay? So, audio signals up to 5 kilohertz can be transmitted. If the carrier frequency daw is 1,000 kilohertz or 1 megahertz, so meron kang carrier na 1 megahertz, and the modulating frequency is 5 kilohertz, okay, again, pag nag-modulate ka, nagkakaroon ng sidebands. Tama ba? So, yung sidebands na mapoproduce natin, meron siyang frequency na first, that is 1,000, yung ating carrier frequency, which is 1,000 kilohertz, plus 5. Bakit 5? Because this is our modulating frequency. So, yung first sideband natin, meron siyang frequency na 1,005 kilohertz. And the second sideband has the frequency of 995. Paano? Because that is just your carrier, which is 1,000 kilohertz minus the modulating frequency, which is 5 kilohertz. So, ayan. So, the two sidebands has these frequencies correspondingly. Alright, I hope that is clear. Ayan, so going back again, gusto ko lang siyang ulit-ulitin just to give emphasis, okay? So in other words, modulation process generates other signals. Please do not forget, modulation process generates other signals that takes up spectrum space. It is not just the carrier, say for example, yung ating 1,000 kilohertz that is transmitted. Hindi lang yung carrier because nagkakaroon nga ng sideband. So, it's more than this frequency ang nagagamit. Okay? This not this frequency alone. So thus the term bandwidth refers to the range of frequencies that contain the information. Right? So yung bandwidth mo, you can also say that it is the range of frequency that contain your information. So the term channel bandwidth refers to the range of frequencies required to transmit the desired information. Yung channel bandwidth naman, yun naman yung kailangan mo in order to transmit your information. Okay? So bandwidth of an AM signal described above or kanina is the difference between the highest and the lowest transmitting frequencies. Ayun na yan. So kapag this is your highest frequency, transmitting frequency, according to your channel bandwidth, this is your lowest transmitting frequency. So meron kang bandwidth na 10 kilohertz. So in this case, the channel bandwidth is 10 kilohertz. An AM broadcast signal therefore takes up to 10 kilohertz piece of spectrum. Okay, so although, say for example, in this certain AM signal, although yung carrier frequency natin is 1,000 kilohertz lang, so supposed to be 1,000 kilohertz lang yung nagagamit sa ating channel bandwidth. But because of modulation na nagkakaroon ng sideband instead na yung yung 1,000 kilohertz lang, nagkaka na occupy niya ngayon yung 10 kilohertz ng ating spectrum. So going back to the spectrum, if this is your spectrum, so yung ating AM signal ngayon, nag-consume ng 10 kilohertz na portion ng ating electromagnetic spectrum. So instead na isang frequency lang yung carrier natin, pero the truth is up to 10 kilohertz yung na-consume niya. Okay, that is again because of modulation which causes to create a side bands. Alright? So, additional lang, ito, hindi ko siya nabigay nung previous na topic. So, again, your frequency is just equal to, it has this relationship with your period. Frequency is equal to 1 over the period. And thus, if you want to get the period is just equal to 1 over your frequency. So, kapag given na yung iyong frequency, you can solve for the period. And eto, of course, given din siya, i-reveal lang natin that your wavelength is equal to the speed of light, which is equal to 3 times 10 to the power of 8 meter per second divided by your frequency. So if given na yung frequency mo, you can already solve for your wavelength. Alright? So that's it for this video lecture.